next speaker for the event is Professor Wendy Wen. So Wendy, I'll give you a brief introduction. Thanks for agreeing to talk at the event. So Wendy Wen or Hong Wen is a professor at the University of Electrical Science and Technology of China, which is called as UESTC. This is a premier school in China. She is also the leader of the Efficient and Secure Space Communication Network Research Center at UESTC, a senior member of the IEEE. Her research field mainly focuses on communication security and reliability technology. Her outstanding contributions are to develop lightweight and asymmetric physical layer and AI-based security schemes for IoT systems, which are especially useful for space, air, and ground network security, edge computing security, and mobile terminal security. So Wendy, thanks for agreeing to talk. So just give me a minute, Wendy. I'm sorry about it. I'll just share the screen so that just give me a minute.
Can you hear me? Okay. Now I will share my.
Sure. Sorry about this, Wendy. Wendy is going to talk. If you can see the slide. So Wendy is from UESTC China, and the title of her talk today is Efficiency and Security for Edge Computing Assisted Smart Grids. So Wendy, thanks, and go ahead, and I invite you to start your talk.
Okay. Now I'm going to share my screen. So, but I have difficulty to share my screen because the system told me some other shared the screen, so I can't.
I'll do. Wendy, just hang on. Yeah. I think it's visible now. Yeah.
Okay, visible. Okay. So it's visible for you.
Yes, Wendy. Please go ahead. Yes, it's visible.
Yeah. Thank you. Thank you for your introduction, and it's my great honor to join this meeting and give a talk here. So now I will begin. So good afternoon. Today, my topic will be efficiency and security for edge computing assisted smart grid. I will divide my talk into 5 catalogs. And firstly, I will give a background, and then I will introduce an efficiency smart grid edge computing model, and then give the security issues about smart grid edge computing. Then I will introduce how we build such an edge computing platform, and finally give conclusions. Edge computing is a new computing system and technology which can sync computing power from the cloud to the edge. So this can let edge computing have lots of advantages such as localization, proximity, and network no latency, real-time response, security, and provides the protection. Personalized configuration to meet the different needs of application intelligence.
It's a conference.
So, for the edge computing, we can create value chain, ecological chain. So edge computing can be traced back to the macro center of Cisco in 2016, which with the development of IoT, it was formally proposed with a new attitude. Actually, edge computing is evaluated from the cloud. So from the distributed computing to online program, online computing until cloud computing, and now back to fog computing. Now cloud computing becomes smaller, reduce the cost of near device, and to the edge computing. This is because we need close the device, we need to close the sensors, we need to solve the problem and make decision quickly and need the quickly response. Why? Because by edge supporting, we let machine have intelligence, let environment have intelligence, and by learning and collection data, edge computing is called the last 1 kilometer of artificial intelligence. And so for our grid, power grid, firstly, we began our smart grid edge computing from a 3 cloud edge model. This is a cloud. Cloud can process a lot of information data. Also, data was stored here. Lot of sensors and get the data and put to the cloud. Also, they need data and get data from the cloud. Now we put another layer here. So firstly, such sensor and the device send the information to this layer and temporary storage data here, and then this is a local data process and storage layer. This is edge layer, and then send to the cloud. So the sensor also when they require the data, they can from this layer and get data. So this is local process layer. So this is our first work. We complete this model in 2015 and published in the IE Transaction Cloud Computing. So this is our edge computing model. This model overcomes the drawback of the cloud and provides real-time control that reduce network burden and provide security and privacy. So we give such an example, such as the power line inspection system. In such a power line inspection system, in the past, all the tasks were done by the man, but now by support of Power Grid Cloud, they can do by the inspector managers. They will distribute the task, and the data managers, they will manage the data from all the power line inspection, and they have inspectors. They will perform the task from the manager, and they have system managers. They will maintain all this system. All the data stored on the Power Grid cloud will give the legal data user. So the inspector manager log in and create task, assignment task to certain inspector, and then check the state of task. So they need access authentication, and then access authentication to the data. So in the edge end, the inspector also access authentication and log in, access task full task form and data local process, and then access authentication data encryption to the Power Grid. And then the system manager, they will do local managing and local system maintenance, and the cloud system maintenance. So they do access authentication and the data upload. And the data managers will do data retrieving, data upload, data location, storage, data real process. We say if we have edge and here, we have edge and here, so all the access authentication can do edge end. They do not need to only depend on the power grid, and the data process they can do on the edge end. So and some data will storage on the edge device. So this is our system example. So when the data user, they need access the data, they will ask for the edge end and say, if the data is still on the edge device, they will directly get the data from the edge device. If it had been put in the cloud, they will ask the edge and get the data from cloud and then put to the data user. So this is our model. We need to we built this model. We also need to build practice the system. So this program is duration 3 years. Actually, in this program, we built 5 layers, and our power grid edge computing is in the system level. So now I will talk some detail about smart grid edge computing model. For the smart grid edge computing model, we needed to solve all the drawback now in the traditional cloud computing pro system that cannot satisfy real-time control. The network traffic is heavy. Network instability bring process interruption, which cause unreliable control. Basic requirements such as security and provider protection cannot be effective guaranteed. So we put our edge computing model as first layer is cloud service platform, and then this is fog computing layer, and then here is edge computing platform. So then from the edge computing platform is physical world, including sensors, terminals. So we call this cloud layer, and this is fog edge layer. And for edge device, this device will consist of terminal communication module, and this is cloud, and this is edge device. Also, we call it as edge saver. They will have edge gateway and agile controller. Sometimes agile controller is a part of edge saver put into here. So this sometimes these 3 parts are separate, and sometimes these 3 parts are get together. And then there will be terminal here. They also have their own data center. Edge computing can provide security and provider protection, but also they have its own security problem, because it is very close device, very close sensors. It can be attacked very easy by these terminals. So we consider if terminals need to access to the network, we need to do authentication. We divided this authentication into three status. The first were authenticated terminals. This is security smart grid network. And the second is partly authenticated terminals. And this is security gate edge computing device. So this is partly confidential terminals. And third one is unauthenticated terminals. This is in security public network. So three different terminals were located on the different network layer in the smart grid edge computing. So the smart grid network will treat all the data from these three kinds of terminals as different methods. Due to the edge computing, it is possible to enable billions of devices to connect into the IoT in the smart grid. By this way, the smart grid network can become more intelligent. Even if unauthenticated data also can accept the network, only they will give a guard to these terminals and can do more interactions with the user while the security risks become higher due to the opening IoT face time of attacking every second. In such application, EC play a mid connection nodes between in security public network and the security smart grid network. So to such scenario, we will for the smart grid edge computing, they will face such different terminals. So put a security framework here. Because for the smart grid, different applications need different security protection. From efficiency and security purpose, we proposed such scalable and secure access control scheme for edge computing terminals. So they will do access authentication. They will do three different kind of authentication. First is physical access authentication. And second is encryption-based access authentication. And third one is cross-layer access authentication. Physical layer access authentication. Most authentication will do by the edge computing, and terminals almost do nothing. And for the encryption-based access authentication, and the terminal and edge computing will do same work. So if terminal is resource and computing constrained, so they will do physical access authentication. So cross layer is in this two, in the middle of this two part. Then there will be data security. Data, they will do data transmission protection. They will face heterogeneous data storage protection. Heterogeneous data separated. So we use IBE heterogeneous data access authentication. So and this will filter the data and the data provider protection. Then illegal user want to get this data, they can't. Finally, is real-time sensitive protection, because sometimes some task is real-time control. So we should avoid real-time attacking. So for the real-time tasks, we will do real-time track detections and keep tracking and perform time and keep time we will use time inverse stream protection this task to be performed in certain time in requirement time. So our contribution for the smart grid edge computing, mainly we provide advanced physical feature security technology that combined with cryptographic multi-level security system realize the physical and data level protection of edge devices and achieve high security access protection of computing power and resource constrained node terminals on the edge device. Why? Because for this is a model and this is central management platform, not a different terminals. This terminal will access to the edge device. Due to the terminal will be different type. Maybe there will be have different frame and different data frame. If use encryption authentication, there will be a hard task. But if we use physical feature security, so we can do unified authentication faster. Do the fast access because most task was due by the edge device and the terminal do nothing. So node terminal security access based on physical features, they can achieve lightweight and rapid authentication. Also, it is hard to clone and unable to eliminate it. This is because we full use the computing power of each device. This is because we use the fingerprint of the device. Depend on the edge computing resource, we can use artificial neural network and such a powerful algorithm to do net the authentication rate of physical features is very high. So this is our platform. This is our edge devices. So if computing capacity resource constrained weak computing or low computing power nodes, so we can solve these nodes, and this is the waveform we collect from this this device. So we noticed this is almost the same, but they have different waveform here. So we can hear they have different waves here, just as our finger. This is called fingerprint. So we use edge device process this fingerprint. So edge side will provide the computing resource and do the authentication. So this small device do nothing. Also, the physical layer authentication can do munition nodes detection. This is lightweight recognition technology. They can detect kernel node attack very easy because for the kernel, you see here these nodes, they have two kernel nodes here. This is legal nodes. They have 2 volition nodes here. If they have, we found they in the different location, but they have different channel responses. So we can claim that kernel nodes attack. So we can, by capturing the deployed nodes, attacker can obtain all the information. So in the traditional security authentication scheme, this is hard to detect, but by our physical layer approach, we can use such lightweight technology. Only check the channel response, and we can know, okay, whether this is kernel node or this will be NIC nodes. So they also will do by the edge computing edge device. So we have 4 scenarios for our private provider needs. The first is mobile terminals. User need to know their location information. The second is mobile terminals. User need to prove they are legal use a certain device, but do not want others to know they are use a certain device. And scenario 3, when the equipment is repaired, the user's information on mobile terminal with character range is needed, but information is illegal acquired, including the data managing. Scenario 4, many businesses require anonymity, such as a per user request. So in edge computing, avoid leaking or intercepting user provided information, such as location information, device identification, device identification, due to edge computing network device deployment and operation nodes. So such provider information in edge computing database is not acquired. So for this purpose, we built our edge platform. This is our edge platform, and this is parameter, and this is par concentrator, and this is edge device. And edge device will combine the 2 parts, and one is so we enlarge this part, and actually the size is small. We enlarge here. This is edge saver, and this is edge gateway. And for the edge gateway, they can analyze our protocols for major power equipment. Now 26 different communication protocols for industry can be analyzed for this edge gateway and get the data, and this data will transmit to the edge server. So this edge gateway will do data collection. And this gateway can support, one gateway can support up to 200 terminals. And edge server gets the data, they can complete application functions here, and they can do real-time control, agile control, and they also can do many of tasks, and also have edge server also have their data center to do the data storage. And they also can have disk or SD card, manual backups the data. And they will regularly report to cloud and do interaction with the cloud. So they complete application functions. So we do power grid monitoring system, energy measurement for power grid, intelligent energy system. We have built such 3 systems and use our edge platform. So, such the construction of our edge platform built, the total scenario will be like this. This is edge device here, and they will connect to the cloud, and most sensors will connect to the edge system, and our software will development under the fireplace framework. So I gave several examples. The edge computing is used to predict the electricity price and identify the malicious behaviors. Charge pile, this is a charge pile. And the charge pile analyzes our power source node characters and optimize for the peak node regulation model. All this will do in the edge computing and do location strong volatilities and random analyzes the local balance and dynamic characters, and the node characters identify our power generation source and consumption. So the edge computing is also used to distribute autonomous power grid here, and actually we use a graph model to denote the grid model. This is not of user here. We use a node denote a user and use a graph model, and this is distance is the real distance or between the user. So in this node, we can do buy and sell and find the best seller and the best buyer. So in this graph node model, we have grid connection point, grid generation, intersection, and macro network controller, power supply, and energy storage, import node, general node. And so we give the node properties. So we also do the blockchain for the distributed power grid edge. We use blockchain and do the record their buy and sell. So finally, we built the whole scenario of this edge computing system. In this system, UAV is used to inspect the power line, and the robot and the sensors all will be connected to the edge computing, and all this edge computing server will connect with the cloud and provide intelligence for the full grid power. Thanks and questions.
So thank you, Wendy, for the nice talk. And I think I don't see any questions unless any of the panelists has any questions.